Oil paint dates back to ancient times, when artists mixed minerals and other elements with wax or oil. In the 1400s, they discovered that linseed oil was ideal as a pigment binder because it allowed blending and glazing in layers. Centuries later, the colors in those paintings are still vibrant. Today, many oil paint pigments still come from natural sources, though most are synthetically made. Factories buy both types of pigments in powdered form to make their paints. Cuttlefish ink yields brown pigment. Lead produces a specific yellow, and mercury ore makes red. In the past, pigments have also come from stones, tree bark, plant gum, ground up glass, and even arsenic. This company's research laboratory spends about 2 years developing a color recipe. A chemist mixes specific amounts of linseed oil and pigment into a machine called an automatic Mueller. It rubs the ingredients together, dispersing the pigment particles throughout the oil. For each sample, the formulation is altered slightly in search of the perfect result. The research team compares the resulting colors and selects the best one. To produce a color on a large scale, workers start by pumping a specified amount of linseed oil into a mixer. Then they add the precise amount of pigment. Most colors are made with just one pigment. The precise mixing time and speed depends on the kind of pigment formulation being created. Next, the mixture is spooned into a mill. 3 dispersion rollers rub the ingredients, separating pigment particles and coating them in oil. The recipe specifies how much pressure the rollers apply, how fast they turn, and how long they work the mixture. Milling can take hours or even days, depending on the texture of the pigment. The quality control lab takes samples from each batch coming off the mill and subjects them to a series of tests. Technicians scrutinize paint from both sides of the mill to ensure the mixture is being processed evenly. First, a spread test. A heavy brass weight goes onto a blob of paint for a prescribed period of time. Then, inspectors evaluate the volume of color and measure the distance it spread. If it doesn't spread far enough, it needs more milling. Next, a dispersion test. The markings on this gauge indicate the size of the paint's particles in microns, millionths of a meter. If the particles are too big, the paint hasn't been milled enough. Finally, inspectors time how long it takes the paint to dry to the touch. Each color has a specified drying time, ranging from 2 days to 2 weeks. The factory produces a chart that displays its 120 paint colors. Workers brush each color onto a primer-coated paper. When the paint dries, they cut each bar into rectangular swatches called chips. The chart is assembled using this mounting machine. The bottom has a section for chips of each color. And the top contains a cardboard chart coated in glue. As the machine closes, each chip aligns perfectly with its designated spot on the chart. Back on the production line, the factory packages one color at a time in toothpaste-style tubes that will be finished off with twist caps. Once the labels go on, the tubes make their way to the filling machine. There, the tubes have their tops screwed on. A nozzle squirts in the paint. Then clamps flatten the edges shut. A roller folds over the edge to strengthen the seal against squeeze pressure. Now, these oil paints are finally ready to meet the canvas.